out there as well. Okay, so we were looking at our number guessing game as methods. So we can have parameters for methods, right? And then you have to give them these values when you call the method. So like print too high, too low. We're passing these arguments to the method here. And then the method can use them inside of its code block here. So inside of its set of curly braces, it now has a guess and a random number variable that it can use to do whatever it needs to do here. Okay. So some methods don't have any arguments. Some methods do have arguments. Right? Ask for a guess, given the highest number did. Some will return a value. Right? So we can take a new variable here, int highest number, and assign it whatever we're getting back from here. Just like math random gave us a new number, right? We could create a variable using this method here. So math.random is a method in the math class. And then some methods, just like print too high or too low, they don't return any values. They're void types. So void methods don't return anything. They just run. So we can do lots of cool things in our methods then, right, to put a name to what's happening. So we get a nice name for our code, even if we only are doing it one time. Right? Ask if you want to play, sure. Ask how high to guess, ask for a guess. And then we're using ask for a guess over and over and over again. We're only using ask how high once. Right? We do ask if they want to play more than once, right? That's the part that runs in our loop here, or this print have a nice day, we're just doing once, but it lets us kind of organize our code and break it down into smaller and smaller and smaller chunks. Do that thing, the functional decomposition, my favorite word, my favorite technical term, right? Taking a big problem and breaking it down into smaller and smaller and smaller chunks, because we can solve smaller problems a little bit easier than we can solve bigger problems. So we just kind of put it all together like that. So a couple other interesting things when it comes to methods. Let's see, where do we, those ones there. No, because we didn't do the lab yet. So we were looking at turning lab 4, right, essentially into, or not lab, whatever that, the shape printing one, into methods there. That was the lab we're going to be working on. Where we can use these sort of values or these sort of methods to do a lot of the same sort of work. So one of the things we can do, so instead of like ask for a guess given the highest number, is you could have another method. Did we do that one? I don't remember if we did or not. You could ask for a parameter to be passed of like the string for the prompt. And then you can pass that, whatever it is, that we can use that in the print line. Then, so like, hey, enter the size of a square, or the height of a rectangle, or the length of a rectangle. And the only thing different there is the string value. We're still doing this integer parse int of whatever they're typing in, so we can repeat that portion of it pretty easily. Let me see if I have that one in here. Having trouble remembering back to last week already, folks. I'm sorry. Oh, so we got to talk about the nested loop lab. That's right. So let's talk about this one here for lab 6. We start a new project for lab 6. Lab 6 for Monday, Wednesday. So this is a loop within inside of a loop here, right, to build out these fun little shapes. And then for lab 7, right, we're going to take this one and add some methods to it, right? Let's see if that's, I think that's what it was. Yeah, so we're just going to add a new shape and then do it all with methods. So we'll look at like one method here. So that like the method given the size, argument as a parameter, for printing shapes, for prompting values, validation loops. You can do all sorts of fun stuff with those. But let's go back to 6 then. We'll look at those nested loops. All right, so we're going to use that scanner. We'll call it keyboard. There's a new scanner given system in. Okay, so we can get some user input, and then we're going to ask them what shape they want. Oh, we got our input. Yep, thanks NetBeans. And the import, we'll ask what shape do they want. What shape do you want to print? And we had square, we had rectangle, and we had triangle, right? And one of the things we wanted to do was make sure they gave me one of those values, right? As like a little validation loop. If they don't enter one of those, keep them in the loop until they enter a valid shape. So we should do this then inside of a loop. So we need a string for the shape here. And I'm going to start it off as something that is not valid. So I can say, while shape.equals, hey, thanks for following along. Glad to have you here. While it equals square. So we're going to say, well, it does not equal square, right? With this not operator, well, it's not square and it's not rectangle and it's not triangle. So if it's not square, it's not rectangle, and it's not triangle, if all three of those are true, hey, 1,000 followers, that's so cool. Awesome. It's like a big number, right? So if it's not square and not rectangle and not triangle, so if any one of these, if it is, right, so if we entered square, this would be true, and we're going to say not that. So not true would be false, and because we're anding together, any false makes the whole thing false, and the loop will stop running. So we can do our little validation loop here with this to make sure we get a proper shape then. And we can say, okay, now if the shape equals ignoring case, kind of repeat some of these here. If it's a square, oh, not square, if shape equals a square, then we need to go do the square thing, right? Else if shape is the rectangle, we'll go do the rectangle thing. If it's not that, else if. Now you could probably just get away with an else here because we know it's only one of them, but I think it's fine having another if. Not going to be too big of a deal here. Okay, so if it's square, then we need to ask for the size. So the size square you want, and then we'll have an int for size. Right, is going to be the integer.parseInt of the keyboard.nextLine. Right, we'll convert whatever we get. No, not instance of. I don't know why that one keeps popping up. That one happens a lot to me. Right, so size, and then we'll go print the square size. Right, for rectangle, we'll say enter the length rectangle you want, and then we'll get a length. And then we're going to repeat for width, right? Because you need a length and a width for rectangles. So we'll say width and width. And then for triangle, we just says what? We just says what? Can't talk, friends. Enter the, I don't know, size triangle. Why not? And just call it size again. I don't know, is size easy? That should be fine. Maybe is that base or height? I don't know. It's a right triangle, so it doesn't matter too much. Okay, so we'll get those values, and then we can do the loops to print these things out. Right, so for the square, we did square already in our loops section. So that was, we're going to say for int row is 0, row is less than size, row plus plus. So for every row in the size, we want to do something. Well, what do we want to do? We need to print a bunch of stars. So for then column, int column is 0, column is less than size, column plus plus. So for every column then, we want to print, and now we want print, not print line, because print then is just going to keep stacking all those prints on the same line for us here. Then once we've printed every column, right, every star, outside of that loop, we can print a line to go down to the next row. So for each row, we're going to run every column start to finish, and then print a new line, and then we'll go to the next row. and print the star, start to finish, go print the next row, print the next row, print the next row. So it's basically the same thing for rectangle, but now we have two different values. We have rows are less than our length, but columns now are less than our width. Right? So for every row in the length, we'll do something, and for every column in the width, we'll do something. And I think those are probably backwards, right? Let's do width and then length. Because I think triangles are supposed to, or rectangles are supposed to be wider than they are tall. I don't know. It's fine. So generally, you'd probably imagine the length is longer, and I'd rather have my rectangle not be super tall, but rather wider, because we have more room to be wide for the rectangle. Okay, and then for triangle now, this was the interesting one. We said it says 1 for the first row, 2 for the next row, 3 for the next row, 4 for the next 5, and on and on and on and on. So for every row, we're printing one more star here. So it's a similar approach here. So we're going to say for row in size, we're going to print something here. Now, I'm going to cheat here, and I'm going to say row starts as 1, and I'm going to go less than or equal to size, because this is going to make my life easier. So if row starts at 1 here, then I can say, hey, column then is less than row. Because at row 1, then I want to print 1 star. When row is 2, I want column to run twice and print 2 stars. When row is 3, I want column to run 3 times and print 3 stars. So 0 is less than 1. Or we could just do this. We could leave it at 0, say less than or equal to the row. There we go. How about that? Does that make more sense then? So at row 0, the first row, again, it probably seems funny to start at zeros. You'll see why that's useful later once we talk about arrays. Most of the time we start things at zeros. I don't know. It's just a habit. So if you started at 1, that's no problem. Not a big deal at all. Oh, ouch. Swallowed wrong. Oh, that was uncomfortable. All right, let's see if this will run. Let's see if we can get our shapes. Nope, we have to do this compile and save thing. It's the worst setting. Worst setting. All right, run lab 6. All right, what do we want to print? Let's try the triangle. And to the size, let's do size 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 stars. So there's a little 10 by 10 triangle. Run it again. So let's say we want to print a diamond. Now, what shape do you want to print? I don't know. How about a rectangle? Hey, Marv. Hi, thanks for coming along. Java's the best language. It's a lot of fun. All right, what length? Let's do 10 by 5. So 10 rows, or I'm sorry, 10 columns by 5 rows. So this kind of looks more like a square, I know, but just our spacing is a little bit off. If these were packed a little tighter, maybe it'd look a little nicer. Excuse me. Okay, so that was our lab for nested loops. How did that one go for you folks? Right, loops within loops. Lots of loops. So validation kind of loops, or loops that run, pretty shapes. We can put loops inside of loops to do some fun things. All right, I'll commit this one to GitHub here. Oh, excuse me. Phone keeps beeping at me here. Oh, it's my sugar. I'm drinking tea. I'm not drinking anything with sugar in it. That's weird. Here, put that on fuzzy mode. Let's go to 1500 Monday, Wednesday. And we'll commit lab 6. All right, there we go. Take a little more insulin. All right, app 6. All right, some other fun things we need to know about methods now. You can close app 6 down. Is when you are passing values here, so this like print too high or too low, something you can do if you want to, we can say, hey, let's take random number and let's set it to, say, 42. And we'll make it not so random here. But what's going to happen is it's not going to change the random number here. And that's because of a funny thing that happens. So when you pass values to methods here, so we're saying, hey, here's my int for my guess, here's my int for my random number. When they are passed as these primitive types, they're passed by value. So you get a copy of that value. And changing it will change it inside the method, and that's it. So we can say, so primitive types are passed by value. You get a copy. So changing it here won't change the value in the main method. So we can watch that happen, right? So if we come over to our program here and we put a breakpoint in at line 20. So click over at line 20, you get a nice big red square here. Usually it's a dot, I don't know why they're squares. Big red square, that's a breakpoint. And we hit run with debug mode. Instead of run, the one with the line numbers here, we can see the value of all of our variables as the program's running. Super cool. So we have to go, let's see, do we want to play a game? Yes, we want to play a game. And so it's going to pause when it gets to that line. So it hasn't gotten to this line yet. So we're still doing this part of the number here. So let's guess 1 to 100, guess a number, we'll guess 50. Now it pauses. So it got to the line that had the breakpoint, and it pauses for us. It breaks and waits for us now, and we can see the value of everything. So I can see the random number is 81. It's a little small on your screen, sorry. I can see my guess was 50. I can see my number of guesses was 1. I can see the highest number is 100. I can see play is Y. So a couple other things here we don't really care about. We'll get to those later. Okay, so now if I do step over, it's just going to run that code and go to the next line. So what I want is I want 2 buttons over. I want the little down arrow here that says step into. I want to go into the method. And now I can see, hey, we're here at the method at line 67, print too high or too low. And now the only thing I can see here are the variables guess and random number. These are the only variables that are in scope. Remember, scope is where that variable is defined, where you're allowed to use it. So because they were defined inside of main, you can't use them anywhere else. That's it. It's the only place you can use them. Okay, so we only see the things that were in scope. So we see guess was 50, we see random number was 81. Now we're going to step, and now random number changes to 42. Okay, sure, we'll print too high, too low. So it was too high. And now we come right back to where we left off. We finished line 20, now we're on to line 21. But we can see random number is still 81. And changing it inside the method didn't change the value back here, because we passed those values, those arguments by value. We passed a copy of them. That's an important distinction. We can ask for a guess. We have to go back here. All right, let's guess 81. Number of guesses goes up. Guess does not equal random number is false, and our program stops. So we guessed it in 2 guesses. And I'm just going to hit continue. It'll just run to the end here. And no, we don't want to play again. We're all done. So apparently it's supposed to be pretty warm today, right? Melt a lot of the snow, and then tomorrow we're supposed to get more snow. Is that what's supposed to happen with our lovely Michigan weather? Okay, so you have to be careful with your methods. Okay, cool. Like, the kids are excited to go sledding. Now, a method like, oh dear, we don't have one in our guessing game here. Sorry. Caught that cough. I'm gonna have to go get some more hot fluids here in a minute. My throat's killing me. If we were to pass something like a string, yeah, we can chat after SP Java for sure. If you were to pass something like a string to a method here, so let's just say, let's do, what do we want to do for a method that has a string? Here, let's do one here. Let me go reopen here our lab, and I want to show you one. I'll give you one freebie method here. So remember, methods are defined outside of main. So outside those main curly braces here, let's make a public static, and I want a method that's going to return an int. We'll say ask for an int, given what we're going to call is the prompt. So if you give me a string prompt, then I'll ask for the integer. So I'm just going to, I'll make a scanner, call it keyboard equals a new scanner, given system.in, and then we can just print out their prompt, right? Whatever you told me, I'll ask the user for. And then I'm going to get some value, will be the integer.parseInt of the keyboard.next line. So whatever they type in, we'll turn it into an integer, and I can return that value. So this, then, when we're like asking for things here, like what size square do you want? Instead of saying that, we can just say size then is going to be ask for an int, and we can pass it this enter the size square you want. And we can do this all kind of in one line here then with a method. And then this is reusable, right, for length, for width, for size, all those sorts of things, anytime we're using it for that. But now you'll notice string here is not a primitive type. It's not an int, it's not a float, not a double, not a char, not a boolean, right? So it's not passed by value. What that means then is we're passing the memory location of where this string is in memory, which makes a lot of sense here. Because remember, oops, that's not what I wanted. That's not what I wanted. I want WinWord. Word. There we go. So when we tell Java we want a place to store some information here, right? The Java says, hey, operating system, I need a location to store something in memory. I want to store a string. So the operating system says, sure, you can have x23fb. And for some reason, they're in hexadecimal. I don't know why. And then there in that memory location, we can store, you know, have a fun snow day, or whatever we're going to store, right? We can store that string in memory at that location. So when I call a method and I say, hey, I want to give you a string here, I'm going to give it, wow, that's not even a capital H there. There we go. I'm going to give it the memory address. I'm going to give it the reference here to prompt for int. Right? So it says, okay, sure, here's the address of where this thing is. Because if I were to make a copy, strings can be really big, right? I know an int is only 4 bytes. They're kind of small. It's pretty easy to make a quick little copy. But strings, it's 2 bytes for every character. And the bigger the string is, right, the more bytes of memory it's going to take. So instead of making a copy, it just says, hey, here's where it is in memory. You can go read it out of memory here whenever you want it. So how about we have a string for the prompt here first. I just want to illustrate this is what's going to happen here. So I have a string for the prompt, and then we can ask them for an int here with that given prompt. Right, so it'll make this string in memory somewhere, and then when we call ask for int, it's going to pass the memory location of where does this live in memory? Where is this object in memory? Then I can go use it. Now, what that means is if I try and go change prompt, it might change because I know where it is in memory. Now, strings are special. Strings are immutable. Immutable? I think there's 2 M's there. Means they can't change. So what happens anytime you try and, quote, change a string, it's making a new string in memory. So that's really like changes maybe. It's not really a change. Remember, there's a couple fun things you can do with strings. So we could say prompt dot to upper, like if we wanted to make it all uppercase and yell at people and use our outside voice. So prompt to uppercase isn't going to change prompt. It's going to make a new string here. So if I want to change the value of prompt, I'll have to say prompt equals prompt.toUppercase. So that creates a new string and points prompt to it. So what happens then is inside of my method here, right, I did have prompt, and it was pointing over here. And we just said, hey, we're going to make a new string, say, in all uppercase. So, hey, operating system, I need a location to store a new string. So operating system says, sure, how about 3221? And we store in all uppercase, right, have a fun, da, 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 da. And now prompt doesn't point here anymore. It points to this one. So we can change where our string value points to here, but it's not going to change the prompt back in main, right? Even though we're passing it by reference, right? We're not passing a copy, we're passing the reference to it. Because strings are immutable, they can't be changed inside of functions. So this doesn't change a string stored in memory in main. Right, so prompt doesn't change. So we run this one. Oh, I was going to do debug mode. That's right. Let's go back and do debug mode. Let's stop. Try with debug mode. We'll see that it's going to change inside the method here, but not back in main. So what shape? That was a square. Square. I can't type S-Q-U-A-R. My goodness. Square. There we go. So the prompt here is enter what size you want. Here. That's the prompt. Now we're about to change that to uppercase. So we'll see now. Did it not? I didn't change. It should have changed. I'm confused. It didn't change it. What? Did we skip that line? What happened here? One more time. I'm confused. Square. Step. There we go. Okay, I must have skipped it somehow. That's super weird. I don't know what happened. And now we see what size square do you want? All uppercase, shouting, yelling here. And then we print it out. We get the value. We'll just say like 5. Sure. Thanks for yelling at me, computer. And we come back. Now prompt inside of main is still the original version. Right? It can't be changed by the method here because strings are immutable. So that's a special property of strings. Other things that we pass, you could change depending on what they are. And we don't really have lots of good examples of that yet. But when we start talking about classes next week, then we can start doing fun things like that. Okay? So we're going to look at that for methods that they can pass values by value if they're primitives, or they're passed by reference if they're objects. Here, and then this, using this as a method is a nice little hint here for the next lab, is you can just save the time doing this all as one prompt every time here. And then this could be the, print a square for a given size. You can pass the size to it, that sort of thing. Your validation loop could be a method, like ask for a valid shape, and it won't return until that loop is done. So then we can just assign shape to like ask user for valid shape. We got some options there. Lots of fun things we can do with methods. Let me take a peek real quick, see if I'm missing anything else. Give me just a moment here, sorry. So how are you folks feeling about methods so far? Making sense? Methods and arguments. We needed to do input validation. That was the next thing, that's right. So one of the things we can do then, too, is say if we are asking for a guess here, right, is that if I enter something that is not a number here, oh, sorry, I meant to say yes, bad habit. Can we run the lab again? Or run our chapter 5 methods? Which one? So if it says how high of a number, if we say 10 spelled out, we see it's going to crash here, this number format. Yeah, square and triangle one, sure, this lab. Do that one. Which shape do you want to do? Oh, the one that changes uppercase. Yeah, the square. So then square says, oh, it'd help if I could spell square. We get the enter the size square you want. It was all uppercase. And then we can say 10, and we get our 10 by 10. It's not exactly square shape, but it's close. Hey, segment graph, thanks for coming along. Yep. So with our methods here, then, if I enter something that's not an integer, it's going to crash, and that's no fun. So what we can do is we have a way of avoiding crashing, which is super cool. So to do that, then, we use this try and catch. So if we know something might crash, like this integer parseInt here, we say, I'm going to start what's called a try block. And anything that might crash goes inside the try. And then we say, hey, I want to catch. And what could happen here is a number format exception. I'm going to call it exception. No, exception. And if that bad thing happens, you can print out just the exception here. There's lots of information in that exception. But now, guess isn't defined because it was declared inside the try block. So we need some sort of loop then that's going to keep on running here until we get a valid guess. So let's actually, I'm going to put this inside of that here because I want this to happen over and over and over. And then I can say, while true, do this thing. And then inside of my block, I can return the guess. Now this looks really funny. It looks like it's an infinite loop, but all it's saying is if an exception happens here, catch it, don't crash, print it out, and then go back up and try again. Because what happens with an exception is the code stops running at that point in time. So if an exception happens, it stops running and jumps to the catch. So this return line never runs if there's an exception here. Or I should say it is skipped. So if there's an exception, it just skips this line and goes down to the catch to do whatever we told it to do. In this case, it's just printing out the exception. So let's try this again. We guess a number. Let's do up to 100, guess a number, and we say 10. We get the number format exception for input string 10. Not really the best error message here. So you don't always want to actually print the actual exception. So maybe we just say, please enter only numeric values, right? And we keep on going. So I'm not really sure. I don't do a lot with Spring, unfortunately. Sorry. So if I spell out 50, it says, okay, please enter only numeric values. How about 10 or ASDF, right? 10. Now I get actual results here. So this is letting my program try something that might crash it and not crash, right? So try something that might crash, and then the catch part is don't crash, but don't crash. Do this instead. Right? That's the beauty of a catch block. So the book will take you through a couple different types. I don't like the other scanner methods. I always use next line. I think that makes life a lot easier. I just typed it in. I don't think there was any import for it. There was no special import or anything. It's just the type is number format exception. So, and if you weren't sure what it was, right, you can let it crash the first time and see that, yes, this one will give you a number format exception. So try and catch is super handy then to make sure that if we want something and we don't want it to crash, which is like all the time, like no one likes when their program crashes. For some reason, that's like the most irritating thing that can happen in your day is you're just going along and your program crashes and locks up on you. You're like, ah, and then it's even more annoying when you're a developer because you feel like they should have done better. So anytime we're going to use integer.parseInt now, we can put it inside of this try block. And this, it seems funny here that we say this while true loop. Sorry, I'm missing my curly braces for that. My goodness. Eric, that's bad. It's not really an infinite loop because we know we're going to return out of it at some point. Now, this only really works inside of a method with this return type. If it was just inside of code and not in a method, you could use break. Not usually the biggest fan of break, but that kind of works really well in that particular case. If you want to use a break here. So that's fine. That's definitely an option. But that's the other nice thing with like the method kind of just pulls it off into its own little chunk here, and then it can have its own validation, making sure it doesn't crash on us. And that's every time we ask them for that input, that'll happen. Now it doesn't for ask them how high to guess, which is unfortunate. But you'll notice these are similar here. I guess we're telling them the highest number, so not exactly the same, but they're pretty close. So maybe we could do better, right, if we wanted. Because then I don't want to have to like make this whole loop in here twice, right? We could make this method call this method if we